Students, followed by the projectile motion. Now we are going to discuss about a very important 5-mark question, that is a projectile in a horizontal motion. Consider a projectile. We consider that is a ball thrown horizontally with an initial velocity. A ball thrown with a horizontal velocity u vector from the top of a tower of a height h. Okay, here we consider a ball is thrown with the initial velocity u vector from a height of the tower. The height of the tower is equal to h. As the ball moves, it covers a horizontal distance. Okay, so here the ball is moves from this place to this place. At the time it is cover the distance due to uniform horizontal velocity. We know that the ball is moves with the initial velocity, that is a horizontal velocity, so it has a horizontal displacement. And then a vertical downward distance because of constant acceleration due to gravity. This ball is moves under the gravity, so there is also having the vertical downward distance because of constant acceleration due to gravity. Thus, under the combined effect, the ball moves along the path OPA. We know that already we discussed here the projectile motion. It is combined of two velocity. One is horizontal velocity, uniformly horizontal velocity, and another one that is uniformly changing the velocity. Okay, uniformly changing the horizontal velocity, increasing or decreasing. Okay, vertical velocity. So like this, there's under the combined effect of the ball moves the path OPA. The motion is in two-dimensional plane. There is having this displacement in x-axis and y-axis. So this is moves in the two-dimensional plane. Let the ball take time t to reach the ground at a point A. Okay, now we consider the time taken by the ball to reach the ground, that is noted by letter t. Then the horizontal distance traveled by the ball means how you can calculate the horizontal distance. Horizontal distance means velocity into time. So we can write the horizontal distance traveled by the ball is calculated by using the formula of x of t is noted by letter x, and the vertical distance traveled by the ball is noted by letter y is equal to h. So we can take y of t is equal to y. We can apply the kinematic equations along the direction and along the x direction and y direction separately. Okay, we can apply the kinematic equations along the x direction and y direction separately to calculate the displacement along the horizontal direction and the vertical direction. Since this is a two-dimensional motion, the velocity will have both horizontal components u of x and vertical components uy. Motion along the horizontal direction, the particle has zero acceleration along the x direction, so the initial velocity is ux remains constant throughout the motion. The distance traveled by the projectile at a time t is given by the equation x is equal to velocity into time, that is ux into t plus half at square. Okay, so you know the formula from the kinematic equations. The displacement y is equal to ut plus half at square. That formula only is changed to x is equal to uxt plus half at square. Since a is equal to 0, at initial position the particle has zero acceleration along the x direction. Along the x direction there is no acceleration. Along the x direction at initial position there is no acceleration. So we can take it as a acceleration is 0. That is substitute in this equation means here this equation is modified to a is equal to 0. So x is equal to ux into t. The motion along the downward direction, here uy is equal to 0. Uy is equal to 0. Motion along the downward direction. So the velocity along the y direction, the velocity along the downward direction is 0. Initial velocity has downward components. Here this object is accelerated due to the acceleration due to gravity, so we can take the acceleration of the particle a is equal to g. We choose the positive y-axis in downward direction. The distance y at a time t is calculated from the equation y is equal to uyt plus half at square. We get y is equal to half gt square. Already we know that here there is no initial velocity along the y direction, so uy is equal to 0. So uy is equal to 0, substitute in this equation means y is equal to half gt square. Substituting the value of t from equation 2.23 in equation 2.24. From the equation 2.23 we can take the values of the t. What is the values of the t? T is equal to x divided by ux. Is substitute in this equation means what is the values of the y? Y is equal to 1 divided by 2 g into t square. What is it mean by t? T is equal to x divided by ux. Is substitute in this equation means x square divided by ux square. In next step it can be written as gx square divided by 2yx square into x square. Sorry, gx square divided by 2ux square. Okay, so that only in the equation is given g divided by 2ux square into x square. So from this we can write y is equal to k into x square. Here the k is a constant value. Constant values means here g acceleration due to gravity, 2 is a constant, u means that is a initial velocity. Initial velocity is also constant. So we can write that is y is equal to k into x square. Here what is the values of the k? K is equal to g divided by 2ux square is constant. Equation 2.25 is the equation of the parabola. Thus the path followed by the projectile is a parabola. Okay, this is the path traveled by the object is one of the parabola. That is a horizontal projection. So from this projectile motions, now we are going to discuss about the time of flight. What is the meaning for time of flight? The time taken for the projection to complete its trajectory or time taken by the projectile to hit the ground is called time of flight. Okay, and the time taken to reach the ground is called time of flight. Consider the example of a tower and a projectile. Let h be the height of a tower. Let t be the time taken by the projectile to hit the ground. After being thrown horizontally from the tower, we know that Sy is equal to uyt plus half at square. For vertical motion, here Sy is equal to h. The displacement is not is known as height of the tower. So Sy is equal to h. T is equal to t. Uy is equal to 0. Okay, the initial velocity along the y direction is 0. So uy is equal to 0. That is no initial vertical velocity. Okay, initially the ball is moves with the horizontal velocity only. There is no initial velocity. So we can take uy is equal to 0. Then we can write what is the values of the h. H is equal to, that is a displacement, vertical displacement. Y is equal to half gt square. So we can write h is equal to half gt square. So what is the values of the t? T square is equal to 2h divided by g. So from this what is the t? T is equal to root of 2h divided by g. Thus the time of flight for projectile motion depends on the height of the tower. We know that the t is directly proportional to the height of the tower. But it is independent to the horizontal velocity of projection. There is no value of the horizontal projection, horizontal velocity. So here the time of flight is independent to the horizontal velocity of projection. If a ball falls vertically and another ball is projected horizontally with the same velocity, means both the balls will reach the bottom at the same time. This is illustrated in the figure 2.40. Here we are taking these two balls. Both balls are dropped from certain height. One ball is moves with the horizontal velocity, and the another one there is no horizontal velocity, means it is reached the ground at the same time. We know that Sy is equal to uy t plus half at square for the vertical motion. This is a displacement. Okay, we can take here Sy is equal to h, that is equal to height. So we can write Sy is equal to height. T is equal to t. T means that is the time taken for the projection. Uy is equal to 0. Initially for the particle, there is no vertical velocity, so uy is equal to 0. So we can write h is equal to half gt square, so t is equal to root 2 h divided by g. Already we discussed. Okay, so from this we know that the time of flight is directly proportional to the height is independent to the horizontal velocity of the projection. Okay, next, horizontal range. The horizontal range means the horizontal distance covered by the projectile from the foot of the tower to the point where the projection hits the ground is called horizontal range. Okay, so what is the meaning for horizontal range? That is one of the distance covered by the projectile from the foot of the tower to the point where the projectile hits the ground is called a horizontal range. This is a horizontal range. Okay, so for the horizontal motions we have sx. Sx is equal to uxt plus half at square. It is the values of the horizontal range. Here sx is equal to r. Okay, that is a horizontal distance traveled by the projectile. So sx is equal to r, that is equal to range. Ux is equal to u, initial velocity along the x-axis, that is u. A is equal to acceleration, no acceleration along the horizontal direction, so we can take a is equal to 0. The t is a time of flight, so the horizontal range is calculated by using the formula of velocity into time, that is ut. Since the time of flight t is equal to root 2h divided by g, we substitute these values, we get the values of r. R is equal to horizontal range, r is equal to u into what is the values of the t, that is root 2h divided by g. We substitute this equation means r is equal to u into root 2h divided by g. So the above equation implies that the range r is directly proportional to the initial velocity u and inversely proportional to the acceleration due to gravity. Next, resultant velocity. The resultant velocity is the velocity of the projectile at any time. Okay, at any time t, the projectile has the velocity components along the both the x-axis and y-axis. The resultant of the two x-axis and the resultant of the two components gives the velocity of the projectile at the time t is shown in figure. Okay, so resultant velocity means velocity of the projectile at any time. At any instant of time t, the projectile has the velocity components along the both the x-axis and y-axis. Here we consider the point P. In a point you can calculate the velocity of the particle. It has a initial velocity and it has a horizontal velocity and it has a vertical velocity. So from this, at any instant of time t, the projectile has the velocity components along the both the x-axis and y-axis. So the resultant of the two components gives the velocity of the projectile at any instant of time. That velocity is called the resultant velocity. So the velocity of the component at a time t along the horizontal axis x-axis is calculated by using the formula of v along x-axis is equal to ux plus axt. Okay, so this is the general formula to calculate the velocity. Alright, since ux is equal to u, the acceleration, there is no acceleration along the x-axis, so a is equal to 0 means it is substituted in this equation, we get the values of the vx is equal to u. Okay, it is the formula from the v is equal to u plus at, that is a kinetic equation, v is equal to u plus at. From the formula we are taking vx is equal to ux plus axt. Here there is no acceleration along the x-axis, so ax is equal to 0, substitute in this equation means vx is equal to u. Next, the components of the velocity along the vertical direction, y-axis. The vertical direction is calculated by using the formula of v is equal to u plus at, so vy is equal to uy plus ayt. Here, since already we know that there is no velocity along the y-axis at the initial position, so uy is equal to 0 and the acceleration is dependent upon the acceleration due to gravity, ay is equal to g. So this equation is replaced by uy is equal to 0 and ay is equal to g. We get the values vy is equal to, this term is 0, here ay is equal to g, so g into t. Hence, the velocity of the particle at any instant of time is calculated by using v vector is equal to u I cap plus g t j cap. So, the speed because here we consider the resultant velocity is one of the resultant of the two components gives the velocity of the projectile. So the velocity of the projectile at any instant of time is also given by the v vector is equal to Vx is equal to u. So only here we can write ui cap, Vy is equal to gt plus gt j cap. Okay, so the speed of the particle at any instant of time is given by the v is equal to root of vx square plus vy square. So v is equal to root of, what is the values of the vx, that is u square, plus vy means that is a gt, so g square t square. Next, the speed of the projectile when it hits the ground. When the projectile hits the ground after initially thrown horizontally from the top of the tower of height h, the time of flight is given by the t is equal to root 2h divided by g. The horizontal component's velocity of the projectile remains the same, so vx is equal to u. So the vertical components of the projectile at a time t is calculated, vy is equal to gt, so we can write g. The values of t substitute in this equation means root 2h divided by g, so we can write g, it can be written as root g into root g, root g cancelled remains, that is root of 2gh. The speed of the particle when it is reaches the ground is v is equal to root of u square plus 2gh. Thank you, students.